Have you ever tried to find a needle in a haystack? I mean, I haven't because there isn't exactly a load of piles of hay lying around Cork City, but I've heard it's pretty tough. So, thankfully, I have good news. I think I've managed to figure out this age-old problem. What if you could just get rid of all the hay? It'd be way easier to find the needle, right? But why aren't people applying this to science? Imagine that the hay is now drinking water and the needle is liquid mercury. You wouldn't want to eat your way through the hay to try and find the needle, so why would you drink through the water to find the mercury? So how do we check that our drinking water is safe to drink without just giving it to our younger brother and hoping for the best? Well, the answer lies in my research into microfluidics. By using microfluidics, you can separate out the heavy metal from the liquid and detect it easily. But what is microfluidics? Well, if you separate out the two parts of the word, there's micro, or small, and there's fluidics, which means, well, fluids. But microfluidics is so much more than just that. With microfluidics, you can manipulate the properties of fluids or liquids, such as their rate of flow, just by understanding the physics underlying it all and using relatively small volumes. So let's talk about flow. And I don't mean the same kind as Eminem does. So in my work, there are two types of flow. There's turbulent and there's laminar. Now, for anyone who's been on an airplane before, you know that turbulent is usually a bad word to hear. And it's the same in the world of microfluidics. Turbulent flow, everything is just going all over the place and it's impossible to try and detect a specific part, which isn't great for using a sensor. With laminar flow, it's the complete opposite. Everything is behaving nice and ordered, and it's really easy to detect a specific part. So we want everything to be laminar. To give you an example, imagine turning on a tap and turning it on way too strong. All the water shoots out everywhere. That's turbulent. But imagine turning on that tap really slowly and it just kind of drips out. That's laminar. So to bring it back to the heavy water, imagine that sample of heavy water and you could send it off to a lab and you'd wait about a week before you get your result, but you'd probably be pretty thirsty by then. So what if you could get your result in a minute and have it more accurate too? By using laminar flow, By using laminar flow, there we go. By using laminar flow, you can direct the heavy metal and separate it out onto the surface of your sensor, and you can get your result in a minute and have it more sensitive. It being more sensitive means that you can detect a smaller amount than even the lab equipment can detect, all by using my beloved microfluidics. Finding the needle in the haystack has never been easier or faster.